Welcome to machine learning's new frontier. Today we explore 126 breakthrough papers submitted on October 9th, 2025, highlighting advances in fairness, efficiency, and discovery. This episode spotlights the future of AI-driven innovation, real-world impacts, and the key insights shaping tomorrow's artificial intelligence. Here is your guide to today's breakthroughs. We will unpack the most influential themes in current machine learning research, highlight real-world applications and their societal impacts, and simplify technical concepts for broader understanding. 3 seminal papers that are shaping the field will be spotlighted, and we will offer a glimpse into the future directions of AI. What is machine learning? At its core, this field teaches computers to learn from data, rather than relying on explicit programming. Machine learning powers recommendations, diagnostics, and self-driving vehicles by adapting to new problems, often surpassing human intuition. The field has evolved rapidly, from theoretical foundations to technologies with substantial real-world influence. Today's research continues to push the boundaries of adaptability, fairness, and efficiency, ensuring that machine learning remains at the forefront of technological progress. A key theme in the latest research is robustness and fairness. Ensuring equitable AI is paramount, especially as conditions and data distributions shift. Pham and colleagues introduce FairTTE, a framework that uncovers bias in medical imaging prognosis. Guldigan's work on conformal prediction provides fairness in confidence intervals, aiming to ensure equitable treatment across diverse groups. The stakes are high, with applications in healthcare, justice, and equal opportunity, yet achieving robustness under distributional shift remains a critical challenge. Decoding black boxes through interpretability is another crucial focus. As machine learning models grow more complex, understanding their decisions becomes increasingly difficult. Zhao and colleagues present surrogate explanations for time series forecasts, while Lin's group utilizes SHAP values to reveal the importance of features in predictions. Interpretability supports trust and accountability in AI. Surrogate modeling, where simpler models mimic complex systems, helps clarify the logic behind predictions, fostering transparency in machine learning applications. Efficiency and scalability are making powerful AI models accessible on all devices. Kwun and colleagues' LOTION framework smooths quantized training, allowing large models to run efficiently on edge devices. Liu introduces frequency-aware caching, which reduces the computational costs of diffusion models by reusing features. DYNAMIX applies reinforcement learning to dynamically adjust batch sizes for optimal efficiency. Quantization, or the reduction of numerical precision, is a key technique for speeding up models. The overarching goal is to bring advanced AI capabilities to everyday technology, from smartphones to sensors. Reinforcement learning and decision-making continue to drive smarter agents and real-world impact. Reinforcement learning enables agents to learn optimal strategies through trial and error. Jane and colleagues show how large language models can guide RL agents in complex tasks. Pascoe's work enables robots to transfer skills across different bodies using dimensional analysis, while Fenwick leverages RL to optimize CT scan protocols for enhanced patient safety. These methods excel in dynamic and uncertain environments, demonstrating the real-world applicability and flexibility of reinforcement learning. Representation learning and the theory of generalization are teaching AI to see the bigger picture. Marvey and colleagues draw inspiration from human visual sparseness to create more efficient models. Liu's structure-aware encoding injects relational context, enriching the representations learned by AI. Berman's work reveals surprising linearity in certain neural network architectures. Representation learning focuses on understanding the hidden structure within data, while generalization ensures that models perform well on new, unseen information. These advances drive adaptability and robustness in modern AI systems. Key findings from the analysis of 126 papers reveal significant leaps forward for machine learning. Fairness tools are shown to struggle under shifting real-world conditions, underscoring the complexity of equitable AI. Efficient quantized training unlocks the potential for deploying advanced models on edge devices. DemoDiff enables flexible molecular design using only a handful of examples. Causal analysis exposes deep, persistent biases within datasets. Notably, the merging of theoretical foundations with practical applications characterizes the best research emerging today. How are these breakthroughs achieved? Several methodologies were central to recent advances. Surrogate modeling uses simple stand-ins to explain the behavior of complex models. Diffusion models generate data by progressively refining random noise, a technique vital for modern generative tasks. Reinforcement learning optimizes decision-making through feedback loops, enabling agents to learn from their environments. Structure-aware embedding maps relationships within data, facilitating deeper learning. Finally, fairness and causal analysis trace and mitigate bias at its roots, ensuring more equitable outcomes. The first featured paper, The Boundaries of Fair AI in Medical Image Prognosis, a Causal Perspective by Pham and colleagues, tackles fairness in medical prognosis, a domain where life and death decisions are made. The motivation centers on ensuring fair predictions as AI integrates into clinical workflows. The FairTTE framework enables fair, causal time-to-event predictions, uncovering widespread bias and demonstrating that current fairness interventions offer limited improvements, especially under distribution shifts. This work sets new standards for trustworthy healthcare AI, chosen for its rigorous methodology and real-world significance. The next seminal paper, LOTION, Smoothing the Optimization Landscape for Quantized Training by Kwun and colleagues, addresses the challenge of making large models practical for devices with limited resources. The motivation lies in the growing computational and energy demands of modern neural networks. The LOTION framework introduces randomized rounding to smooth the training process, resulting in better accuracy and convergence for quantized neural networks. With its theoretical guarantees and success in real-world deployment, LOTION bridges the gap between advanced AI and practical, edge-based applications. The third highlighted paper, DemoDiff Graph Diffusion Transformers are In-Context Molecular Designers by Liu and collaborators, advances the field of molecular design. The motivation is to create new molecules with minimal data, a crucial requirement in drug discovery and materials science. DemoDiff leverages demonstration condition diffusion models, allowing it to match or outperform much larger models in molecular design tasks. This methodological innovation opens the door to rapid and flexible advances in chemistry, making it a standout for both novelty and broad practical potential. Where is machine learning heading next? Emerging directions point to holistic fairness and robust causal reasoning as key priorities. Efficient adaptation, where models learn from minimal data, is becoming increasingly important. Inspiration from biological systems continues to shape new algorithms. Bridging mathematical guarantees with practical success remains essential for trustworthy AI. Persistent challenges include ensuring fairness, improving interpretability, and maintaining scalability as models grow more complex. This summary was created through a rigorous synthesis and review process. Text analysis was powered by GPT 4.1 from OpenAI, while TTS narration was generated using OpenAI audio tools. Visuals accompanying the presentation were produced with Google Image Generation technologies. All content underwent review by human experts to ensure accuracy, although minor oversights may remain. Full references for all discussed papers are provided for transparency. Thank you for joining us on AI Frontiers. For more cutting-edge AI insights, subscribe to our YouTube channel for weekly research breakdowns. Join our community to stay ahead in artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.